Hi everyone, today we're going to continue in chapter number 7, looking at reactions that form double bonds, otherwise known as an elimination reaction. Generally, the elimination reaction involves the loss of some group X and some group Y that are on adjacent carbons, and they ultimately form a double bond. So, for example, X might be a good leaving group and Y is an acidic hydrogen. Usually, one group is electronegative and the other is electron releasing. And this is also possible for other atoms besides carbon to form this double bond. But today, again, we're just going to be focusing on carbon-carbon double bond formation. So elimination reactions often accompany substitution reactions, and sometimes you actually see them as a minor product. In the two reactions shown here, substitution is still the major product. And we've talked about substitution in our previous chapters. However, the yield of the substitution product is not fully 100%. In fact, we see this minor product in each case occur. That is an elimination product in which we form a double bond. This is kind of was noted previously when doing substitution reactions, and how this type of reaction came to light was through the process of substitution reactions. Again, generally the key pattern for an elimination reaction is that you're forming this carbon-carbon double bond, a pi bond, and you have to break two other single bonds on a carbon. Usually we're breaking a carbon-hydrogen bond and forming a new base between the hydrogen and something else. We're also breaking a bond between a carbon and a leaving group. Now remember, good leaving groups are usually weak bases, and then forming our double bond. Usually a strong base or acid is going to catalyze this reaction. I'm going to get in more into what you will see catalyzing the reactions and how to determine when you have an elimination reaction near the end of this lecture. But again, you're forming a conjugate acid. This is a base that has picked up your proton, and the leaving group is also removed, and you're forming a double bond. Generally, all else being equal, elimination reactions are favored over substitution reactions with increasing heat. This idea will be brought up again later when we're talking about distinguishing elimination from substitution. But when all is equal, if you are deciding between a substitution and an elimination, generally elimination reactions will start to increase in likelihood for a product as you increase heat. Now, notice this isn't an on-off button. Generally in organic chemistry, you have this gradient, right? So as you increase temperature, it's more likely that you form an elimination reaction and less likely that you form a substitution. But it's not an either or. There's still generally, again, all things being equal, both being formed. It's just you're tuning towards which product you would likely form.